today we're doing our last section of 8.4, or chapter 8, which is 8.4. And what we're going to learn about today are plane curves and parametric equations. So by the end of today, you're going to be able to sketch a pair of parametric curves. Right? Notice it says pair, so there are going to be two of them. And then you're going to express parametric curves in rectangular form. Okay, so what are parametric equations? This is just a general method for describing any curve. So we've already used rectangular equations, we've used polar equations to describe a curve, and that can't describe any curve, so that's why we bring our parametric equations in. Now you have this information box that's going to give you a general form of how parametric equations are going to function. So if you have f and g, which are functions defined on some interval I, so it's just some interval, okay, it'll change based on your question, then you can graph your set of points, which is f of t and g of t. Okay, so x would be the function f of t, y would be the function of g of t. Notice that both x and y are going to have the input of what? Yeah, what is it? What's their input? If it's f of t and g of t? T. Okay, and t represents exactly what you would probably guess it would represent. What would you think it would represent? What do you think t represents? Time, right? Most commonly represents time. That's exactly what it's going to represent. Okay, so your t value has to be in that interval, and then that's going to generate your parametric equations for the curve, and then we call t the parameter. Okay, so the first thing we're going to do is we're going to read through example 1 on page 564. We're actually going to do a little bit of reading before that. So the part up here just explains what I told you. So we've done the rectangular and polar coordinates, and not all curves can be described using polar or rectangular, which is why we study the parametric equations, because you can use that to describe any curve. So you can think of the curve as the path of the point moving in the plane. So the x and the y's are going to be functions in time. So basically, when you're graphing, sometimes you might graph something like this. Okay, you're plotting your points. When you have a parametric equation, your time is also going to play a factor. When you guys see the equations in your book, you'll see the arrows. That describes how it's being graphed. Okay, so it's not only that you're graphing your x and y, but it's how those are being graphed. Okay, so for example 1, I asked you to put these two equations in your calculator. So you're sketching a curve defined by these two parametric equations. And then on your note sheet, I said that the first thing you have to do on your calculator is what? Yeah, you have to change your mode. So if you go to mode, you are now going to choose parametric, which on some of yours it might just be abbreviated as PAR. Okay, so now we're going to go to y equals. Now remember with the y equals, when we were in polar form, instead of y equals, what did we have? We had r equals. Now that we're in parametric form, we're going to have, let's look and see what we have. We have x sub 1 of t, okay, and y sub 1 of t. Okay, so you have two equations for each one, your x and your y, which is perfect because we have our x and our y here. Okay, so your x is t squared minus 3t, so I'm going to do t squared minus 3t. And and then the second one is going to be t minus 1. Oops. Delete, delete, delete. So like the delete button. T minus 1. Okay, so now you know what all of these variables represent. Did you ever wonder why it wasn't just x, why they had all the other ones? They each correspond to a certain mode. So x is for function, t is for parametric, because that's the second one, theta is for polar, and then we haven't done sequential, but that'll be your n. And we will do that later in the year. Okay, so now that I have this, okay, go ahead and graph it. Oh, you mean from your y equals? So you guys have these in from your example 1 in your book, correct? Okay, so now I'm just going to graph it. And this is most likely what you get. So what I ask you is, does this look just like the one that's in your textbook? No. It looks like I have a big part of it, but I'm missing part, right? I can see I'm missing this part of the curve. What do you guys think I have to do? If you can't see the whole graph, what do? You have to adjust your window. So let's think about what we have to adjust our window to. So if you look at example 1, in the table, where does my t value start? No? At -2, right? Okay, so if it starts at -2, I'm going to go to my window, and I better make sure that my minimum is -2 as well, right? If you want, you can go up to the max, which you can see your maximum is 5. My maximum is above that. Okay, so I could go from -2 to 5 to change it. Your step's not going to matter a whole lot for that. And then you can go ahead and graph. Now do I have what matches? Yeah. Okay, so now I have the corresponding t values. So you can even see from this picture, it's labeling what your t values are. Because mine started at 0, I was missing the t value at -1, and I was missing the t value at -2. Okay, so I was missing those points when the t is -1 and then the t is -2. All right, so I wanted to do that to show you how your t interval is going to be important. We're also going to talk about a few other things. Like when you look at this, are you confused why it says t equals -1, but it doesn't correspond with the x-axis here? Do you think you know why? Yeah, why?
Because you're plugging t into both those equations, and then the x and y, that's what you're getting out.
Yeah, so you're plugging in t to find what your x is, okay? But at -1, your x is 4, your y is -2. So the points that you're plotting are 4, -2, right? That's how you're getting them. And we'll do that together, but just something to think about as you notice it. So go ahead and write down your answer to those questions. So did your graph look the same as the one in the text? Okay, no it didn't. And then how did we adjust it? Okay, so in your own words, just write how we adjusted that. Make sure you said something about adjusting the window as your minimum value of t. Okay, so you have to adjust to the minimum value, which was -2. All right, you guys ready to graph one of these yourselves? Been looking forward to it all day. All right. people what they want. Alright, so you have a pair of parametric equations that's given. The first thing we're asked to do is sketch the curve that's represented by those equations. And then the second thing we're going to do is find a rectangular coordinate equation for the curve by doing something that is called eliminating the parameter, which we're going to talk about more in just a little bit. So the first thing I would do when I'm looking at my equations for A and B is notice what my t interval is going to be. So it says that t is between -3 and 3. So I know that my minimum t value is -3. So that's my minimum t value. And then this is my maximum t value. So when you get to step 1, I say to plot the 5 points via the table. That's so if you have on your homework a really big range, like if you had -10 to 10, I wouldn't expect you to write down all of the points from -10 to 10. Okay? I'd expect you to pick 5 of those points and label at least 5 of them. Now for this one, it's really not that much. So for my t values, I'm just going to write down all of them that are in this interval, because that'll be helpful, especially for our first time doing this. Okay, so I'm going to plot more than my 5 points. When you do your homework, you can choose 5 points. But again, it's very important that you have your minimum value and your maximum value. Okay, so you can pick the ones in between, but at the very least, you have to have your minimum value and your maximum value. Okay, what values do you have to have on your table? Okay, so one more time with some gusto. What are the 2 values you have to have on your table? Minimum and maximum. Okay, so now we're going to find our x and our y. Okay, so you can use your table on your calculator, but I also want you to know where these are coming from. If I want to find x and I know t is -3, how can I generate that value? I can just plug it into this equation here, right? So -3 squared is 9, and then it would be minus -21, which would be plus 21. So 21 plus 9 is 30. Okay, so you could generate it that way. -2 squared is 4. 4 plus 14 is 18. Okay, and then you can also use your table. So you would go ahead and you would change your values. Yes.
Will most of them follow like a pattern, or no? Like the axes, like will it go down by same intervals that are like?
Yes, it will.
Will it have like a pattern to it usually?
And it's based on the equation.
Okay.
So when you go to your table, does it have hard edges on it?
What?
You said, why is your graph weird?
It's not a graph.
Oh, okay. So let's finish your table. You have 30, 18. See how you have the x1 and then the y1 and then the t? So you are going to have those 3 columns like we have set up here. So this would be 8, 0, -6, -10, -12. Okay, and then y you could generate the same way, where you could plug in -3. -3 minus 3 is -6. See how this one you're just taking the value and you're subtracting 3 each time? So if you have -2, -2 minus 3, -1 minus 3. Okay? This one follows a very obvious pattern. And that's what?
Decreasing by 1 each time.
It's decreasing by 1 each time, and that's because of your equation. Let's look at our equation. Y equals t minus 3, what type of equation is that? It's linear, right? So if it's linear, it's going to increase or decrease by whatever the slope is. So see how our slope is 1? Okay, that's why why you're just adding 1 each time. For this equation, the x, what type of equation is this? It's quadratic. So remember when you were in Algebra 2, you could figure out from a table whether or not it was quadratic? Do you guys remember what would happen?
Divide and stuff.
Nope, that would be for exponential, we did that. So with the quadratic, it's the second differences that are constant. So linear, the first differences are constant. With quadratic, your second differences are constant. All right, so now we're going to plot these. So like we just talked about, when you're plotting your points, what you're plotting is your x and your y. So when you plot this, you're plotting x, y. Okay, so your first point is 30, negative 6. Your second is 18, negative 5. Then 8, negative 4. 0, negative 3. Negative 6, negative 2. Negative 10, negative 1. Negative 12, 0. Okay, so those are the points that I'm going to plot. And then I want you to remember that these points not only give us the shape of the graph, slash curve, but also show us how the curve is being traced out. Okay, that's why your x and your y are a function of time. So it's not just the shape of the graph, which is what we would do in rectangular or polar, but it's telling you how you're tracing that curve out. All right, so I gave you a piece of this blank paper. Now we have to decide how we're going to set up our scale, where we're going to set it up. So that's going to take a little bit of planning. I have to go out to my highest x value and my lowest x value. What's my highest x value? 30. What's my lowest x value? Okay, so how can I start? How am I going to start my planning process? Am I just going to draw something wherever and hope it works out? Okay, so let's see how much space I have. What's the width of this? 15. Okay, so if I wanted to go by 1s, that's an obvious no. What about 2s? No, because that would only get me to 30 on the positive side. What about 3s? Good. Okay, so 15 times, she's saying 15 times 3 is 45, your spaces, and you only have to go a distance of 42 because 12 plus 30 is 42. Okay, so when I construct this, I keep in mind, oh, okay, if I want this to be, negative 12, then I'm going to have negative 9, negative 6, negative 3, 0. So maybe I want to put my 0 here. You count it out. So I counted it out from negative 12 down to 0. Yep, by 3s. Yep. Okay, now for the y-axis, what's my highest and lowest values? Negative 6 and 0. So those I can go on an interval of 1. Okay, remember you don't have to do the same interval for x and y. We remember that, right?
What if I made my x-axis just in the middle, miserable?
Yeah. Yep, it just has to, it just has to fit it. Okay, so this would be -1, -2, -3, -4, -5, -6, -7. Okay, and then this is going to go by threes, so I'm going to have 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. This will be -3, -6, -9, -12. If you look at your values on the X, it's actually pretty nice because a lot of them are multiples of 3. 30, 18, 0, 6, 12. There's only a couple that we're going to have to estimate. So that is going to make it nice. Alright, so now I'm going to start plotting. So I have 30, -6. And then I'm going to label this as T sub -3. And then I have 18, -5, which is T sub -2. And then I have 8. Okay, so if I'm here at 9 and this is 6, I would say this is about 7, so this is about 8, -4. And then my next one is 0, -3. And that's for T sub 0. And then I have -6, -2, which is T sub 1. And then -10, -1, which I'd estimate to be about here. And then -12, 0. Okay, and then you're connecting those with a curve. This curve looks like it would be part of what type of graph? What special type of graph? Yeah, what do you think, Ben? Looks like it would be part of what?
I was thinking the square root.
Oh, like with that curve, yeah, of the reflection, it does kind of look like that.
Could also be like half of a parabola.
Yep, and it could also be half of a parabola. Yep, that's good. All right, and then now we're going to go to step 2, which is finding a rectangular coordinate equation by eliminating the parameter, which I like this because this is more algebraic. And algebra is my jam, as I like to say. So for eliminating the parameter, what this is going to help us do is identify the shape as well. So this helps us identify the shape of the curve too. So sometimes you're going to have to eliminate the parameter and you won't have to graph it. Okay, so that could give you a good indication about what the graph is going to look like. So the definition, it is just the process of finding the rectangular equation. Okay, and that's going to represent the given parametric equation. So this is very, very similar to what we did with transforming rectangular coordinates to polar coordinates and vice versa. Do you guys remember when we graphed theta equals like 5 pi over 6? If it's theta equals, it's a straight line. And remember when we converted it, it had the form y equals mx plus b. Okay, this is going to be similar to that. So there are 2 steps that I give you. First, you're going to solve for t in whatever you think is the simpler equation. Sometimes it's obvious, sometimes you could use either or, so that's okay. So that's your first step. And then your second step is to use the substitution method. So the first thing you're going to do is solve for t. Then you're going to use substitution. Okay? You use substitution in Algebra 1 when you were solving systems of equations. Okay, so that's step 1, step 2. So this is the second part of our first example. So we're using those same equations. I'm just going to write them here for you so you don't have to keep flipping back and forth. So the x value was t squared minus 7t, and the y value was t minus 3. Okay, so if I'm doing step 1 where I want to solve for t in the simpler equation, this one is going to be obvious. Which one is simpler? The y equals. Okay, because here you're going to have more than one t. So for step 1,
Wait, is this all one problem?
you're going to have y equals t minus 3. Now if you're going to solve that for t, all you have to do is add 3 to both sides. Okay, so now we have t equals y plus 3. Okay, that's your first step. And then you go to step 2. So in step 2, you're going to substitute into the second equation. So we have x equals t squared minus 7t. Okay, so this is what we're going to sub into the other equation. So whichever equation you didn't use for step 1, that's what you're going to use for step 2. Okay, so now we're going to substitute for t. Substitute for t.
On the test, how many of these do you think they'll give us?
As many as possible.
The longest test ever.
There'll be a couple.
We broke it up into 2 days, or?
You'll get your review tomorrow, and then you'll see exactly what you'll have to do. Alright, so now when we plug that in, you're going to plug in y plus 3 4t. And then we're going to go ahead and expand. So this is just a perfect square trinomial. So if I expand that, I'll get y squared plus 6y plus 9 minus 7y minus 21. And then I'm just going to combine my like terms. So I have y squared, and then 6y minus 7y is negative y. 9 minus 21 is going to be negative 12. Now you can leave your equation like this. This is actually a special case. So this is your solution. So you want your solution to be an equation. Usually when you're writing the equation, you want it to have y equals if it's your single variable. See how x is your single variable? Because y has more than one y's in it. Okay, so when you look at the y squared minus y minus 12, you can see that that's what type of equation? It's quadratic. Do you guys know why it's x equals and not y equals? Because it is quadratic. It is going to produce a parabola. What does the x equals do?
The sideways parabola.
This is what you guys would have done your last section in Algebra 2 Honors. Remember you studied parabolas and some of them opened to the left or to the right. This is one that opens sideways. So if it's x equals, the parabola opens to the side. If it's y equals, it opens up or down. Okay, so the shape will be a parabola that opens on its side again, usually when you are writing an equation, you want it to be y equals, okay? Because y is usually going to be your single variable, okay? Sam, were you going to ask me something?
Wouldn't it just depend on which one you solve for first? Like, say if you plugged x equals t squared minus 7t into y equals t minus 3, then wouldn't you get just the y?
Well, you'd have to solve this for t first.
So it'd end up coming out to be x equals again if you did either way.
Yeah, because you would still have more than one y. Yeah. Okay, so for part B, this one's a little bit different. Notice that this one has trig functions in it. Okay, so our process for eliminating the parameter is going to be a little bit different. The process for graphing, though, is not. So when you have that t has to be between 0 and pi, this is one where you absolutely have to be in what mode? You have to be in radian mode. Okay, if this said 0 to 180 degrees, then you would be in degree mode. Okay, so again, we're going to have our 3 columns. Our t, our x, and our y. And I said at the very least, you have to start with your min and end with your max. Okay, now you can decide what intervals you want to use. If you're going to have 5 points, what's a good interval to go by on this? Mm-hmm. You could go by pi over 3. Go by pi over 6. I'm going to go by pi over 4 because I'll have exactly 5 points. Because you have 0 pi over 4, and then you'd have pi over 2, and then you'd have 3 pi over 4. And it would give me 1, 2, 3, 4, 5. Okay, so what we can do, again, is we can graph it and use our table, but we can also plug it in. What's the sign at 0? 0. So then this is just going to be 0. Okay, for pi over 4, the sign at pi over 4 is what? Root 2 over 2. So if I multiply root 2 over 2 by 2, what am I left with? Just root 2. Okay, which is going to be about 1.41. Okay, and then at pi over 2, which is at the top of your circle, what's that sign value? 1, so 1 times 2 is 2. 3 pi over 4 is in what quadrant? Okay, it's in quadrant 2, and the sign is positive in quadrant 2, so it's going to be the same as pi over 4. It'll be root 2. And then for pi, the sign is what?
Oh, you're writing this.
Yeah, I'm writing both of them. Yep. Because if you have root 2 over 2 and you multiply that by 2, they'll cancel out. Okay, and then for your y, if you plug in 0 for cosine, what's the cosine at 0? 1. 1 times 2 is 2. The cosine and the sine are the same at pi over 4, so this is going to be the same. At pi over 2, the cosine is what? 0. Now here, at 3 pi over 4, this is in quadrant 2, which is where the cosine is negative. So this will be negative root 2. So negative 1.41. And then at pi, the cosine is negative 1. So negative 1 times 2 is negative 2. Okay, so now, again, I'm going to look at my scale. So 0 is my smallest x, 2 is my largest. So I'm going to go by halves here. Okay, so I can make this 1 and minus 2.
Can you just write scale by 1/2 and not have to write the number?
Yeah, on the top. And then here I have to go to 2 and negative 2, so I'm just going to keep that same scale. If you are scaling it by that, just if you're doing it for both, just say for x and y. Or if you're just doing it for one, just say what that's going to be. All right, so now I'm going to plot my points. All right, so then the first one I'm plotting is 0, 2. And that's my t sub 0. The next one is 1.41, 1.41. So this is 1.5, so I'd say 1.41 is going to be really close to that. Yes. And then that's going to be t sub pi over 4. Okay, and then the next one is 2, 0, which is t sub pi over 2. And then you have 1.41 down to negative 1.41, which is t sub 3 pi over 4, and then t sub pi. Okay, what do you guys think these points are going to form? Yep, it's part of a circle. Yep. Okay, so when we're doing the circle with the curves, remember a good strategy to do is to do the dashed lines. And then once you have that, you can curve them. Okay, so this is going to be half of a circle from 0 to pi. What value would probably give me the full circle? 2 pi. I went to 2 pi. Okay, so if you were to graph this on your calculator and you didn't have the correct parameters in, you might see the full circle. Okay, but you're only graphing what the parameters are telling you to. So now we get to eliminate the parameter and see what it would look like in a rectangular form. So to do this one, it's really helpful to be able to use your identities. So you can use your trig identities to eliminate the parameter. Okay, and this note is to help you. Okay, in a couple minutes you're going to do this on your own. And I had some people when they tried to do it, they weren't sure how I got all this work. Well, it's all because I'm going to rely on my trig identities to eliminate the parameter. So I'm going to go to my equations here. I have sine and cosine. Do I have a trig identity that relates the sine and the cosine together? Yeah, what is it? Yeah, good, okay. So we know that the sine squared of a variable, which we'll call t to match this, plus the cosine squared is going to equal 1. So similar to the first step where we were solving for t, we're not going to solve for t. What we're going to solve for is the sine of t and the cosine of t. Okay, so we just have to modify that a bit. Okay, so your first step is to solve for sine of t and the cosine of t. So if I have x equals 2 sine of t, and I just want sine of t, I'm just dividing both sides by 2. So x over 2 equals the sine of t. Okay, so I have that. If y equals 2 cosine of t, I'm just going to divide again both sides by 2, and that will give me the cosine. Step 2 is to substitute values into the identities. So sub values into the identity. So if my identity is sine squared and I just have sine, I have to do this value to the power of 2. So this is sine squared. Then I have cosine squared, but cosine is equal to y over 2. So I'm substituting that in, and then of course I still have to have it equal to 1. So I'm going to simplify, so I'm going to square both of these. So I have x squared over 4 plus y squared over 4, which is going to equal 1. Okay, or we could write it as x squared plus y squared divided by 4 equals 1. And because I have x squared and y squared, I want to get both of them just together. So what could I do to both sides here? Multiply by 4. So then I'd have x squared plus y squared equals 4. Now remember earlier we said that this will look like half of a circle. This is the equation for your circle. So this is your solution, which is the equation for a circle. Now really, looking at this picture, you could have checked it to make sure you eliminated the parameter correctly. So for this, do you guys see what the radius is? What's our radius? 2, right? So 2 squared is how you get 4. What's the center of your circle? 0, 0. Okay, so that fits in with the equation for the center of your circle. There is another way that you could do this that I'm also going to show you. So instead of using the identity, you could use the fact that you knew this was going to be a circle. Now this is only going to work if you graphed it to know. But you could use your circle equation, which is x squared plus y squared equals r squared. And then you could plug in your x squared and your y squared. So see how it said x squared was 2 sine of t? I could do 2 sine of t squared plus 2 cosine of t squared. So plugged in x and y that way, which would be 4 sine squared plus 4 cosine squared. And then I could factor out the 4. And what's the sine squared plus the cosine squared? 1. So 4 times 1 will just be 4. And then I'm just going to drop this down. Okay, so you could still get your equation that way. Okay, again, that's knowing that it's going to be a circle. Okay, so I'm going to give you guys a minute to start on number 1 and 2, and you can work with your elbow partner. Okay, so remember, you want to get the single variable on one side by itself. Okay, if they're both single, then it's y equals. Okay, so for number 1, there are actually 2 different ways that you can do this because both equations are pretty simple, right? So let's look at the first method. So maybe you chose this one, the method 1. So the first thing you could have done is you could have chose to solve this equation, the first equation for t. So what would you do to both sides here? Square them. So then you'd have x squared was equal to t. So then when you went to step 2, you have y equals 1 minus x squared. And that's it, you're done. Yep. Okay, so if you did method 2, then your first step would be solving y equals 1 minus t. What I would do is I would add t to this side, and then I would subtract y, which would be t would equal 1 minus y. And then in step 2, you would have x equals the square root of 1 minus y. So remember, if they're both single, we do want to put it in the form y equals so we can see better what the shape of the graph is going to be. So how can I get y by itself? I can square both sides, right? If I square both sides, I have x squared equals 1 minus y. Okay, and then I could, I could just add y to the left side, subtract x squared to the right, and then I have the same equation. Okay. Now, it seems some of us were struggling to remember what your identity is, but remember that you can take your sine squared plus your cosine squared equals 1. If you're trying to get to tangent and secant, you can divide these all by what? You can divide them all by cosine. So if you divide it by cosine, sine over cosine is going to be tangent squared, and then plus 1 equals the secant squared. Okay, so you have to use your identity. Now this one, we don't have to solve for secant and tangent because they're already solved for. See how there's nothing in front of them? Okay, so then all we would have to do is plug in y, bless you. So this is y squared plus 1 equals, the secant is x, so that would be x squared. Now if they're both squares, you want to get them on the same side. Just like with your equation of the circle. Remember how those were both squared, so those would both be on the same side? Okay, so you could subtract y squared from both sides, and you'd have 1 equals x squared minus y squared. Okay, or x squared minus y squared equals 1. Okay, or if you had, some of you have y squared minus x squared equals negative 1.
Yeah.
Yeah, that would be fine too.
How did you get y squared?
Y squared.
Oh, right here? So your tangent, see how the tangent is equal to y?
Oh, yep. And then
Yeah, so it's just y to the power of 2. So before we had like the fraction that we plugged in.
that's nice.
So for that one, it was just the 1.
So you can just change that really quick. It's t with or
Yes, that you can just change it with the t right there. Okay, so you guys are gonna do page 569 from 8.4, and you are doing 3 through 5, 14, 17, 18.
What are the forms of the equations? Either y equals or in the form of
If you have